What if, in a universe we thought we understood, we suddenly found a mirror looking back at us? An Earth so identical, so utterly familiar that it defies every expectation. Imagine the quiet revolution beginning not with a bang, but with a subtle wobble. Deep space telescopes, perhaps next-generation instruments far more powerful than anything currently deployed, detect a faint gravitational anomaly. It's too large to be an asteroid, too small to be a gas giant, and its orbit is unsettlingly familiar. Further observations, painstaking and precise, begin to piece together a celestial puzzle. Astronomers, at first skeptical, then bewildered, begin to whisper a name they dare not speak aloud: Earth's twin. Not just an Earth-like planet, not a distant cousin, but a near-perfect copy. The initial data would be astounding. A planet almost exactly the same size as Earth, orbiting a G-type star virtually indistinguishable from our own Sun at precisely the same distance. Its orbital period, its axial tilt, even its rotational speed, all within a fraction of our home world. This isn't just a habitable zone candidate. This is a carbon copy, down to the most minute observable detail. Spectroscopic analysis of its atmosphere would be the next critical step, a moment of bated breath across every major observatory. The results would send shockwaves through the scientific community and far beyond. Nitrogen, oxygen, argon, carbon dioxide, and crucially, water vapor, all in proportions that mirror our own. Blue skies, white clouds, the very conditions necessary for complex life as we know it. This revelation would immediately challenge virtually every prevailing theory in astrophysics and planetary formation. The rare Earth hypothesis, which posits that the specific conditions allowing for complex life on Earth are extraordinarily unique, would crumble. If another Earth, a true twin, exists, it implies that the cosmic recipe for life-sustaining planets might be far more common than we ever dared to imagine. Planet formation models, once robust, would need radical revision. How could two such identical planets form in different stellar systems? Was it an incredible fluke, a statistical anomaly on a cosmic scale, or does it point to a deeper, perhaps more deterministic, pattern in galactic evolution? The questions would multiply faster than the answers. The implications for astrobiology would be nothing short of revolutionary. If the twin Earth shares virtually identical physical and chemical conditions, the probability of it harboring life, perhaps even complex multicellular life, would skyrocket from speculative to nearly inevitable. Scientists would frantically search for biosignatures, subtle chemical imbalances in the atmosphere that betray the presence of biological processes. Methane and oxygen coexisting, for instance, a clear indicator of active biology. The possibility of finding microbial life would be almost a given, but the real prize, the ultimate question, would be the existence of flora, fauna, and potentially intelligence. Beyond the scientific upheaval, the societal impact would be unprecedented. The discovery of a true Earth twin would be a singular, unifying event in human history, unlike anything that has come before. National rivalries might briefly fade as humanity grapples with this shared cosmic mirror. News channels, scientific journals, social media, every platform would be consumed by the story. Philosophers, theologians, and spiritual leaders would engage in intense debates, re-evaluating humanity's place in the universe. Are we truly unique? Is there a divine plan for two identical worlds? Or are we simply a recurring pattern in a vast, impersonal cosmos? Our sense of identity, our collective ego, would undergo a fundamental shift. The overview effect, usually experienced by astronauts seeing Earth from space, would be scaled up to a global, existential level. We would see ourselves reflected across the vastness. The economic and political landscapes would also undergo radical transformation. A new space race, far more intense and focused than the Cold War era, would undoubtedly begin. Nations and international consortia would pour unimaginable resources into developing advanced propulsion systems, not just for robotic probes, but eventually for crewed missions. The quest for faster-than-light travel, once relegated to science fiction, would become a tangible, albeit distant, engineering goal. Budgets would shift, priorities would realign. New industries would emerge, fueled by the insatiable human desire to explore and understand this cosmic double. Treaties and international laws concerning celestial bodies would need urgent revision, anticipating the day when humanity might reach out to touch its twin. The very concept of national borders could feel increasingly irrelevant in the face of such a monumental shared human endeavor. The first missions would almost certainly be robotic. These advanced probes, potentially utilizing breakthrough propulsion technologies like fusion drives or even more speculative concepts, would embark on journeys measured in decades, not years. Their instrumentation would be designed for extreme precision, high-resolution imaging to map continents and oceans, atmospheric sampling to confirm biosignatures, and eventually landers capable of conducting on-site geological and biological analyses. Imagine the first blurry images returning, showing a familiar blue and green sphere, perhaps with cloud patterns strikingly similar to our own, or entirely alien. The first data confirming liquid water on its surface, flowing in rivers, collected in oceans, would be met with global celebration. The discovery of even rudimentary microbial life, perhaps in ancient fossilized forms or as thriving extremophiles, would confirm that life is not just possible but persistent in these Earth-like conditions. But the most profound and unsettling question, the one that would haunt every discussion, would be the potential for intelligent life. If all conditions are identical, if life arose and evolved along a similar trajectory, would intelligence also emerge? Would there be cities, civilizations, a history echoing our own? The search for technosignatures, radio signals, artificial structures, atmospheric pollution indicative of industrial activity would become an immediate and paramount objective. The implications of detecting an active, intelligent civilization on an identical Earth would be staggering. The Fermi paradox, the contradiction between the high probability of extraterrestrial life and the lack of observational evidence, would effectively vanish. We would have found them, and they, perhaps, would be finding us. This raises an immediate ethical dilemma of monumental proportions: to communicate or not to communicate. The risks of first contact are often debated in theoretical terms, but with an identical Earth, the stakes would be unimaginably high. What if their history mirrors ours, including our conflicts, our prejudices, our technological advancements, and destructive capabilities? What if their development is slightly ahead or behind ours? Should we broadcast our presence or observe silently, following a cosmic prime directive to avoid interference? The very act of finding them, even without contact, would forever alter humanity's perception of itself. The psychological impact of seeing our own reflection, perhaps our own potential future or past, staring back at us from across the cosmos, would be immense. It could inspire unity and accelerate our own development, or it could ignite existential dread and paralyze us with fear of the unknown. The very act of finding them, even without contact, would forever alter humanity's perception of itself. The psychological impact of seeing our own reflection, perhaps our own potential future or past, staring back at us from across the cosmos, would be immense. It could inspire unity and accelerate our own development, or it could ignite existential dread and paralyze us with fear of the unknown. In the long term, the discovery would redefine our species' future. The idea of interstellar colonization would shift from a distant dream to a tangible, albeit challenging, objective. If our twin is truly habitable, it could represent a lifeboat for humanity, a backup planet in case of unforeseen catastrophe on Earth. However, the ethical questions surrounding such an endeavor would be intense. Would we have the right to claim or alter another identical world? Would a treaty be needed to protect its pristine environment, especially if it harbored only primitive life? Or would humanity, driven by a primal instinct for survival and expansion, inevitably seek to reach and potentially terraform or inhabit it, regardless of the consequences? The concept of resource acquisition would also become complex. Could a twin Earth hold rare elements or energy sources that could alleviate scarcity on our homeworld? Or would exploiting it be considered an act of cosmic vandalism? Ultimately, the existence of an Earth twin would force humanity to confront its own uniqueness, or rather, its lack thereof. It would dismantle centuries of anthropocentric thought and reveal a universe far more subtle and repetitive than previously imagined. It would push the boundaries of science, philosophy, and our very understanding of life itself. The mirror across the stars would not just reflect a planet, it would reflect us, asking profound questions about our origins, our destiny, and our place in a cosmos that is suddenly, unsettlingly, and wonderfully, a little less lonely. The quiet revolution sparked by that distant wobble would reverberate through every aspect of human civilization, changing our trajectory forever.